Okay, we're back. Part 2 of 2. Ladies and gentlemen, again, same question as the one you're going to do, except yours is a decagon. This one happens to be an octagon with a radius of 12. I'm going to run through the steps that I just did in part 1 of these videos, but this one I'm going to move a little quicker because this is our second example. All right, so here we go. Now, calculate the area of a regular octagon. So that means there are 8 sides, okay? Radius of 12, I'm coming down here and putting my 12 units there. I'm going to now draw my triangle. Now let's remember, it's an octagon. So how many of these triangles would there be? Right, there would be 8 slices of octagon pie. So now, this triangle is not equilateral. Let's be careful about that. I didn't mention that in the last video. This is isosceles. But what I'm going to do is, I want to just remind you, how do I find the measure of the central angle here? Well, I'm going to take 360, right? Because that would be 360 degrees all the way around, and I'm going to divide that up into eighths, right? So 360 divided by 8 gives me 45. Okay, so that's 45 degrees. So that means my central angle here is 45 degrees. Okay, now if you remember from our last video, we're going to need the height and the base here. So I'm going to draw that, okay? Now, let's think. I have an isosceles triangle with this angle being 45 degrees. So now I'm going to have to find out what these two measures are. Now remember, these two angles should be the same. So what I'm going to do is, again, I'm going to take 180 minus 45. Now that leaves 135 degrees left over, but I have to divide those equally. Now I get 67.5 degrees. It's okay to have a decimal for our angle measures, right? 67.5 degrees. I'm just going to point a little arrow in there so I don't have to write too tiny. All right, so I think we're ready to go here, guys. Now let's be careful. We need to come up with our plan. What's our formula? So we know that we're going to find the area of that triangle with 1/2 its base times its height. But now be careful. In our last video, it was a pentagon. That had 5 sides. This is an octagon. So there will be 8 triangles like that. Okay? So that gives us a little bit of a plan here. So now it says to use trig to find our information. So we want to find the height. I'm going to call this A, and I'm going to call this B. Guys, the one you're going to do, it looks exactly like this, except you'll have a decagon. It won't be 8 here. All right, let's keep it going here. So if I'm looking from this angle, 67.5 degrees, where is A? A is opposite. I know the hypotenuse, which is 12. Opposite over hypotenuse, that's sine. So I'm going to write sine of 67.5 degrees equals A over 12. Okay, so now let's tackle this question here, right? I could put this over 1, cross multiply. I get 1 times A is A, whoops, equals 12 sine of 67.5 degrees. Okay, now I'm going to approximate, right? We grab our calculator, clear it out. 12 sine 67.5 degrees. There we go. You know what's a good idea? Should make sure I'm set to degrees, which we are. So I get about 11.09. 11.09. Now let's remember, what does A represent? That's our height. Okay, good. So now, if we go back to our formula, we could start to plug in our information. 1/2 times the base times the height. Now, I don't have the base, but I just figured out the height. That's 11.09. Okay? All right, finally, let's go get the length of that base. But remember, guys, it's going to take 2 of these for the base. Don't forget to double it. So now, where is B compared to 67.5? It's adjacent over hypotenuse. SOHCAHTOA, I'm going to use cosine. Cosine of 67.5 degrees equals adjacent B over hypotenuse 12. Same thing as over here, except cosine, we cross multiply. B equals 12 cosine 67.5 degrees. B is approximately, I don't know, let's see. So I'm going to do 12 cosine 67.5 degrees, enter. Now remember, it's about 4.59, but that's only half of the distance, so the base is going to be double that. Okay, so again, I'm going to leave my decimal on my screen, times 2. I'm getting about 9.18. Okay, 9.18. Okay, now that's my base. I'm going to replace that right here. So that 9.18 is going to go right here. Okie dokie. We're just about done. Like I said last time, I do want to find out the area of that triangle. So I usually like to type the stuff on the inside. So, whoops. So I'm going to have 0.5 times 9.18 times 11.09. So the area of one triangle is about 50.90. Okay? The area of one triangle is about 50.90. Okay? And now what we're going to do is we should know that there will be 8 of these triangles in this octagon, so I'm going to just click times 8. I get approximately 407.22. As you can hear my kids playing upstairs. All right, so about 407.22 units squared. Your submission should be on Google Classroom, and it'll look just like this, except yours is a decagon with a certain radius. All right, guys, good luck. Let me know if you have any questions.